Hello everyone. I hope you guys are doing great and everything went like perfect this last week. But today we need to continue with what we were doing last class. So let's get to triangles and trigonometry, or better say, let's continue with triangles and trigonometry. Now let's see number 31. In the figure below, triangle ABC is proportional to triangle DEF. Which of the following statements are true? So all that apply. Okay. It says that these triangles are proportional. So, first of all, what proportional means is that all the angles are equal. So in this case, A will be equal D, B of course equal E because they are triangles, and then C will be equal F. Now, we have the following statements are true. So it also apply. Now first, let's establish the ratio between the sides. So I know this side is 4 and this one 5. So this side right here will be x4 and this will be x5. Now we're missing this side and I would like to know the number of this side so I can establish the ratio. So I have a triangle for Pythagoras theorem. I know that c squared equal a squared plus b squared because of Pythagorean theorem, c being the hypotenuse and a and b the categories or the like sides of the triangle. So I know the hypotenuse is the long side, so I have that the long side will be this one, the one opposite to the 90 degrees angle. So it will be 5 squared. Now I have one side, you say well 4 squared, and then I have this other side that I don't know, so I'm going to call that x. So plus x squared. Okay, I will say 25 equals 16 plus x squared. Now I'm going to subtract 16 from both sides and I get 9 equal x squared. And if I do the square root from both sides, I get 3 equal x. So this side will be equal 3. Another thing that you can get in mind is that there are like Pythagorean triplets. So the common ones, like the most common one is 3, 4, 5. So if one side is 4 and the other is 3, the hypotenuse is 5. If the hypotenuse is 5 and one side is 4, the other side is 3. If the hypotenuse is 5 and one side is 3, the other side is 4. Those are the most common. This is the most common one. So it's pretty like useful to know. So I have this, I know that this side is 3, and now I know that this side is 6. So I will say, okay, the short line is equivalent to the short line of this triangle as the long line, for example, is equivalent to the long line of the triangle. So the long line, I don't know, the long line will be x, is equivalent to the long line here, which is 5. So I'm going to cross multiply. 6 times 5 is 30, 3 times x, 3x. So now I have 30 equal 3x, and I'm going to divide both sides by 3, and I get x equal 10, or 10 equal x is the same. So I know that this big side is going to equal 10. Now I want also to know this side, so I have all the information. I could do the same. I could say the big line, the short side of the big triangle is equivalent to the short line of the small triangle, as the medium line, which is the one we don't know. So I'm going to call it y, is at the medium line from this triangle, which in this case is 4. So I'm going to cross multiply. 6 times 4 is 24, and 3 times y is 3y, and I'm going to divide by 3, and I get that y equal 8, or a equal y. Same thing. So this one is 8. Now, it's telling me sine of c 8 over 10. First of all, let's see, this is c, And now for sine, let me use this color. So this is C. Now, I need you to remember this. I think I said it before in a video. Like, so, ka, toa. So, like, will be sine equal opposite over hypotenuse. Ka will be cosine equal adjacent over hypotenuse. And tangent equal opposite over adjacent. So if I'm looking for the sine of a angle, I will say, okay, sine will be opposite, line opposite to the triangle, like to the angle. So opposite, which in this case 4, over hypotenuse. Hypotenuse is the big line opposite to the 90 degrees angle. So in this case 5. So it will be 4 over 5. Now, we could say that 8 over 10 is equivalent to 4 over 5 because if we simplify this, I could say 8 divided by 2 is 4 and 5 divided by 2 is 5 and 10 divided by 2 is 5. Or I could multiply times 2 over 2. And 2 over 2 is basically 1, so we are not changing the equation. And as well, if another thing like that also like make sure that it is equivalent is that they are equivalent triangles, so the angles are equal. So if I go to C, I know that C is the same as F. And if I look to the sign as the sign of F, I see that the sign of F is the opposite, which is 8 over the hypotenuse, which is the opposite to the perpendicular, and is 10. So it will be 8 over 10, which is what we are looking here. Now, tangent of F is 4 over 3, so I'm going to F and say tangent is opposite over adjacent. So opposite is the one opposite to the angle, in this case A, and the adjacent is the one that is like right next to the angle that is not the hypotenuse, it's not the big one. So in this case 6. So I will say, okay, it's 8 over 6. But now, as I was saying before, if I divide 8 by 2 and 6 by 2, 8 by 2 is 4, 6 by 2 is 3, I get 4 over 3. So this is also equivalent. Now, additionally, if I go to the tangent, I know the C go with F, so I go to C. I say, okay, opposite, in this case 4, adjacent, in this case is 3. So 4 over 3. Now, I'm sorry. Cosine of D. Now, cosine, K is adjacent over hypotenuse. So I'm going to go to angle D, and I'm going to do to the adjacent and the hypotenuse. Adjacent is the one right next to the angle, hypotenuse, the big one opposite to the right angle. So in this case, it will be 8 over 10. So I'm going to come here, and I will say 8, okay, wait. 8 over 10. Right here, you see there's nothing like it. If I simplify this, I'm going to get 8 divided by 2 is 4, 5 divided by 2 is 8, 10 divided by 2 is 5. So it has nothing to do with our angle, the angle that we're looking for. So this is not our answer. Additionally, the equivalent of the will be A, and if I look at the cosine, it will be 4, like the adjacent under the hypotenuse, 5. It has nothing to do with 6 and 8. Now, cosine of C. Okay, I go to C. Cosine adjacent over hypotenuse. It will be 3 over 5. And I go here. Okay, this is the exact number they say here. So we're fine. Then let's look at the tangent of A. Gonna go to A. This A tangent is opposite, TOA, so it's opposite over adjacent. So the opposite is 3, the adjacent is 4, so it will be 3 over 4. Right here we have the 3 over 4. So we are fine with those. Now, let's continue. In right triangle LMN shown below, measure of angle M is 90 degrees, MN equals 12, and LM equals 16, which is all labeled here, so we don't need to do anything with it. Now, which of the following statements are true? Wait a second, sorry. So, cosine of n. First of all, to know the cosine, we need to know the measure of this side. So, remember, so, ka, toa. I know I just write it, but either way. So, we need the hypotenuse. So, I'm going to use Pythagorean theorem. I know the c squared is the hypotenuse, the big line, opposite to the right angle. So, c squared equal a squared plus b squared. So c squared, that's the one we don't know, is going to be a squared, which could be the residue, so 12 squared plus b, 16 squared. So c squared equal 144 plus 200. Okay, let's go to the calculator. 256. 56. Now c squared equal 400. Now c equal 20. Because I'm doing the square root from both sides. So this cancels out. Square root of 400 is 20. If you want to make sure, you can add and then okay, let me change that. Square root of 420. So we are good with the side. Now that we know the side, let's do cosine of n. I look at m and I say the cosine is, okay, so k. So it's adjacent over hypotenuse. So I look at the adjacent, the one right next to the angle, which is 12, and then the hypotenuse is 20, so it will be 12 over 20. And when I go here, it says 12 over 20. So we're fine. Now, cosine of n, we already calculated. It is not 12 over 16. We just calculated. It's this one, the one that we just did. Wait. Now, let's see cosine of n. The exact same, we already, we just did it. So it has nothing to do with, that's not the one that we need to do. Now, measure of angle L. Okay. Now, your professor you have told you, but if you're trying to calculate the measure of an angle, you can actually do it with your calculator and the sides of the triangle. So, first of all, this might be confusing, but let's just look at it straight. Without knowing this fact, you can still solve this. We're looking for the tangent, and we're looking for measure of angle L. So I'm gonna go to angle L, and I'm gonna look for the tangent. I know that tangent is TOA. So tangent, opposite, adjacent. So I'm gonna go to the opposite, which is gonna be 12, and I'm gonna go to the adjacent, which is 16. So it's gonna be 12 over 16. And the only one that has 12 over 16 is F. So I know that F is my answer. Now, what I was saying before is that this may be weird because you have never seen the tangent to -1. It's just the way we use for calculating the measure of the angle. So if you go here to your calculator, it could either have the -1, but it could have, okay, they have the -1, but it could have arc tangent or arc sine or whatever. It is used to calculate the measure, okay, in degree over 16. So this angle is 36 degrees or 36.87 degrees, whatever you're looking for. But if you calculate the tangent, without the one, it just give you the value of the actual tangent, which is gonna be always 0 point something. That's basically it for this exercise. Now let's go for the next one. A bird flew from a point on the ground directly to the edge of the roof of the building. Okay, let's draw that. Okay, there's a bird in the ground. There's a building right here. Wait, there's a building right here. And there is a bird flew from here to the roof of the building. Like that. The height of the building is 40 feet. So the height of the building, the height, and the angle's elevation of the big pad made by the bird's fly pad made with the ground is 26 degrees Celsius. So you know this is the ground because I draw this building. So this building is obviously going to be over the ground, and the angle of elevation just means this angle right here. So the angle the bird took to fly to make the transition up. So this angle right here between the bird and the ground will be the 26 degrees. Now, which expression models the total distance in feet the bird flew? So what we need is this. Total distance the bird flew. You know, the total amount of like the total movement he did to move from the point in the ground to the roof. So what we have is this and this. So which what I would like you to think with the SOHCAHTOA with explanation with of the three trigonometric functions we are going to use. So we have here 40 is going to be the opposite. Is the one that is opposite to the angle. So 4 is the opposite, and the x. This is the hypotenuse. Is the hypotenuse like the big line? We have the opposites and the hypotenuse. So if we have the opposite and the hypotenuse, we're looking for sine. So we could say that the sine of 26 will be equal 40 over x because it's opposite over hypotenuse. So the sine of 26 is 40 over x. Now we want to find for x. We want to know the whole path the verb flew. So what we are going to do is, okay, I'm going to multiply x to both sides, and I get x sine 26 equal, and if I multiply x from in this side, it will cancel out, so equal 40, and I want to leave the x alone, so I'm going to divide by sine of 26 in both sides. So let me just do this, you know, x time, and then over sine 26. So it was cancel here, and then x will be equal 40 over sine 26. And this right here is our answer. Now let's continue. You're skiing on a hill and your altitude above the bottom of the hill is 18 feet. Okay, it's right here, so I don't need to draw anything. The angle of depression is 15 degrees. Find the distance x from you to the base of the hill. Okay, here we already have everything labeled. We don't even need to read the whole, like we don't need to imagine the ski or whatever. We just have the angle, the side, and the side we need to know. So this is basically the same of the one before, just easier somehow. Right now, again, SOHCAHTOA, and have here the opposite, and this is the big line opposite to the 90 degrees, so this is the hypotenuse. So I have opposite hypotenuse, I'm talking about sine. So I could say the sine of 15 or sine of x equal opposite over hypotenuse. So I have the angle, so I have sine of 15 going to be equal opposite, which is 100 feet. Over hypotenuse, we don't know it, so it's x feet. So I'm going to do the same, multiply both sides by x. I get x sine 15. 15 equal 100. Now I'm going to divide both sides by sine 15, and I get x equal 100 over sine 15. So now I go to my beautiful calculator and I do this. 800 divided by sine of 15. And it's about 3091, which is right here. Let me use another color. Something important, you guys, I want you to remember is this. You see, the number changes because there are two types of angle or two types of trigonometric values, in degrees and in radians. Radians is something that you're going to worry like later. For now on, you just need to make sure you're working with degrees in your calculator, because if not, it can be messed up. So just be careful about that. And some ways to make sure it's working, you can put sine of 30 and it will be 0.5, because if you're doing it radian, weird number. So if you put times 30 and it's 0.5, you're working with degrees. Just a quick thing. The calculator must say it either way. Now, let's continue. In a right triangle x, y, z, the length of the hypotenuse yc is 85 inches. So let me draw the triangle. So I have my triangle. It's right here. And the length of the hypotenuse, okay, x, y, z. The hypotenuse is 85. Now, and tangent of c is 3 over 4. So it will be 3 over 4. Where the lengths in inches of the legs x, y, and x, z. Now, you might be asking, why did I put an x next to the 3 and 4? It's because this answer is simplified. Based on theorem, on theorem is explained last week. I actually didn't explain it very well, sorry about that, but I put a video that did explain it well. The side of the triangle needs to be like the sine of this side plus this side needs to be greater than this one. The same for all the sides. So obviously 3 plus 4 is not greater than 85. So I know that you simplify the answer like we did here. Here, because f was 8 over 6 and 8 over 6 you can just get simplified to 4 over 3. So I know there is some factor, maybe they divided by 4 or by 5 or whatever, they get that number. So based on that, I could use my trigonometric values to get the answer. Okay, I have the tangent. Okay, the tangent. Oh, also, I put the 3 here and the 4 here because I know tangent is 2. So it's opposite over adjacent. And so I know this is the opposite. So this is going to be 3x or 3 something. And then the adjacent here. So this is going to be the 4. Now I can use my other trigonometric values, for example, actually, there's an easier way to do it. We know Pythagorean theorem. We know that the value we divided the two sides is equal, so we're using the same variable. So I could say 3x squared, or wait, let me use the formula from the beginning. So we know Pythagorean theorem, so c squared equal a squared plus b squared. C squared, it will be hypotenuse squared. So I know the hypotenuse, the big line, which is 85. So 85 squared equal a squared. A could be either of the two sides. So I'm going to say 3x 3x squared plus the other side is 4x, so 4x squared. So first, let's go to our calculator. 85 times 85 is 7,225. So 7,225 equal 3x squared is 3x times 3x. So 3 times 3 is 9. X times x is x squared. Now, let's see here. 4x squared is 4x times 4x. So 4 times 4 is 16. X times x is just x squared. Now, let's continue here. I'm going to add these two together because they are equivalent. They both have the x squared, so I can just add them. So I will say 7,225 equal 9 plus 16 is 25, so 25 squared. Now I will divide both sides by 25. So this cancel out here, and 7,225 divided by 25 is 289. 289 then will be equal to x squared. And now I use the square root, 289, and I get 17. So 17 equal x. Now if I want to know the length of the sides, I will say, okay, xy is 3 times 17, which is going to be equal 51 if I'm not mistaken, but let me just check. Yeah, 51. So 51, and then xz is 4 times x, so 4 times 17, which is 68. And that's our answer. Now let's keep going. The figure represents the side views of a rectangular frame of metal shelf. Two diagonal braces support the frame. What is the closest to the mirror measure of x? Okay, now what we have here. Okay, first of all, this is a um rectangle. So I know this side equal this side equal this side, this diagonal, so this big side is equal this big side, and then therefore, since they are intersecting in the middle right here, this side are all equal, like this little like this triangle. So this triangle is going to be isosceles. That's what I wanted, like this is what I wanted to conclude. The thing with this problem is that you need to know the properties. So as soon as I see a rectangle, I know this, I know this and this. I also know this is equal to this one. I also know they intersect in the middle. So these four little sides are equal to each other. So based on that, I know what is my answer. Because let me explain you why I know. So first, if these two sides are equal, I can say this is an isosceles triangle. An isosceles triangle have equal angles at the base. So if these two sides are equal, this is the base. So this angle must be equal to this angle. And I can actually know the value of this angle because of this. You know, this big triangle, we have the measurement. So I can know the value of this angle. I can use my SOHCAHTOA because I have the opposite here, no, the opposite here, on the triangle, and I have my adjacent here. So I know that because of TOA, This is tangent. I can say that the tangent equal the tangent of an angle x, equal the opposite over the adjacent. So I could say that the tangent angle x, a divided by 2 is 4. The tangent of angle x is 4. Now this correlates to what I said before. The tangent -1. This happens in this situation. So we want to know the measure of the angle. So I'm going to say that the angle, or you can put angle like this, just give it a variable, like whatever variable you want. I can say that the value of this angle will be tangent -1, or the arc tangent, which is right here, arc tangent of 4. So I'm going to go to my calculator. I will put tangent -1 and I put 4. And I get the measure of my angle, which is about 76. This 75.9. I'm just going to say, going to round to the closest number, which is 76. I know that the value of this angle is about 76 degrees. So because of that, this angle right here will also be 76, because they are base angles of an isosceles triangle. Now, we know that the sum of the angles inside a triangle is 180, so I will say 76 plus 76 plus x, that's the angle we don't know, is 180 degrees. So 76 plus 76 is 152, plus x 180. And now I subtract 152 from both sides, and I get that x equal 28. This is the answer. I know it's complicated, but trust me, if you don't understand, just send me a quick message through Discord. I'll help you. That's my purpose here. And I'm just gonna do that one and keep going the next week. I hope we finish the next week. Let's see. A fence forms a right triangle with the edge of a campground and a picnic area, as shown below, with dimensions in feet. Okay, part 8. Which of the following equations can be used to determine the value of x? Okay, without looking at the answer, let me look by myself. I have this and I have this, and if I look, this one is the opposite. Look here, this is the adjacent, because this is the hypotenuse, the big line, opposite to the 90 degrees. So opposite, the one like going a straight line with the angle, adjacent, the one that goes right next to the angle. So if I have opposite and adjacent, I know this is going to be TOA. So it will be tangent equal opposite over adjacent. Now, I want to know, tangent of the angle. So it will be tangent of the angle. Generally, you're going to use this, like this figure, because it represents like the angle itself. So now we want to know x, and x is an angle. This is basically what I did before. If we're going to calculate the angle, I will say that the angle is going to be equal tangent -1 or sine -1, because sine -1 is all, like they all have an opposite property, like an opposite equation. So tangent -1 opposite over adjacent. So in this case, it will be tangent -1. The opposite is 48. So 48. Adjacent is 14. So over 14. Here we go. Tangent x. Look, they use an x. Oh, either way, it's just like this. They didn't take it so far away, but just for you guys to know, they are actually asking for the value of x now. So we do need to know it. So first of all, this is the first equation, this one. Now, to know the value, we keep calculating, and we get tangent negative 1, like, angle equals tangent negative 148 over 14. So tangent negative 148 over 14. And the angle is about 74. Oh, they say exactly? Okay, they say round to the nearest 10. Always be careful with this. Nearest 10 is 1 point after the decimal. So it's going to be the 73.7 because this number is less than 5. So it states 70, oops, 73.7. And this is the answer. So that's all for today, and sorry for the quick lesson. But I'll see you guys next week, and we'll continue working with the trigonometry of the triangles.